Welcome to our video on exponents practice work. As always, pause the video to practice first on your own, and then unpause the video when you're ready, and we'll go over these together. Okay, so the first ones are write an expression for each of the following. And this is about translating our verbal descriptions into mathematical expressions. That's the focal point of questions like this. So the first one is x to the fifth power. And so x is our base and our exponent is 5, so that would be x to the fifth power. Now, the second and third ones get into some very specific vocabulary. So 5 cubed. Cubed is a shorthand way of saying raising something to the third power. Now, you don't have to say cubed. You could say 5 to the third power or 5 to the power of 3. You could say 5 with an exponent of 3. All of those things would technically be correct, but we tend to shorthand that to 5 cubed. For the third one, we have a very common vocab word for squared. And squaring is a shorthand for saying raised to an exponent of 2. Now, I do want to take a little bit of a moment. I do have a short on this if you'd like to see this in another format, but why is this called a squaring? If you picture, it goes back to area. If you were to picture a square has the same length sides. And so if you had 4 and 4 and you were trying to find the area of the square, okay, that would be the formula for area is base times height. And so this would be 4 times 4 or 4 squared, because that would be the area of the square. For cubing, it's something similar, except it would be a cube. And instead of area, we'd be talking about volume. And volume is length times width times height. But if it's a cube, then all three of those dimensions would be the same. So you'd have the same length, the same width, and the same height. So it would be 5 times 5 times 5, or 5 to the third power, but that's why we would use that as our shorthand, and we'd say 5 cubed, because that could be the volume of a cube. So those vocab words don't just come out of nowhere, they are grounded in some of our geometry and some of our other math concepts, and it might help you remember those vocab words if you know where they came from. Okay, the next three are about expanding the expression, and this is really just making sure that we understand what the exponent goes with, and it's a critical idea here is that the exponent only goes with whatever is to its immediate left. So in that first one there, problem 4, we have 4x cubed, but the cubing only goes with the x. So when we go to expand that, it is the x that is multiplied in 3 times there, not the 4. Now that's different from problem 5. And what makes it different are the presence of those parentheses. So the squaring goes with whatever is immediately to its left. And so immediately to the left of the squaring is the parentheses, which means it's the parentheses that are being squared. So this would be 4x times 4x. Now you can write that different ways. So the parentheses indicate multiplication, but if you're more comfortable, you could say 4 times x times 4 times x. Or sometimes people will collect all the like things together, and so we'll use the commutative property right there, and we'll switch the order of the x and the 4, and we would say 4 times x times x. Now, if the directions only say to expand, then all of those would technically be correct answers. You would want to just be careful about what your teacher is asking you to do or what the expectation might be in your class. Now for number 6, this one taps into a really, really common mistake, okay? And so we want to remember that the exponent only goes with what is immediately to its left. So once again, that 4 goes with the parenthesis. So it is the parenthesis that is being cubed. And so we would have, not cubed, raised to the 4th. So we have x minus 3 times x minus 3 times x minus 3 times x minus 3. Now, for the purpose of this video and where we are in our study of exponents, we're not going to try to take that any further and make it look like number 5. We're not going to do that because that involves some math that's a little bit further down the road that would come. So this is what we would do with the expansion. Now, a common mistake people will make, though, is they'll try to take that exponent of 4 and they'll try to apply it to the x and the 3 separately. So they'll say x to the 4th minus 3 to the 4th, but that doesn't work. And you'll have to check out the video on order of operations to see why that doesn't work. So you really want to remember it's only with what is to the immediate left. So if that immediate left is a parenthesis, then it's everything included in that parenthesis, but that does not equate to just applying the exponent to everything inside. Great. The next 3 are evaluate, and you might want to look back at a previous video to know what the word evaluate means, but essentially it means plug in a number and then tell me what it's equal to. And for purposes right now, it's probably in your best interest to expand it first. So the first one is 5x squared, so that's 5 times x times x. So that's 5 times 2 times 2. 5 times 2 is 10, and 10 times 2 is 20. You don't really need to do that many steps up. Okay, now you might be saying, well, couldn't I do the squaring? Couldn't I do it this way and say 2 squared is 4 and 5 times 4 is 20? Yes, that also works. What we want to be a little bit careful of at this point is why would we do the squaring and not the multiplication? So somebody would look at it that way and they would say 5 times 2 is 10 and 10 squared is 100, and they would end up in the wrong spot. So that's why I would say at this early stage, if you're just new to exponents, it's safer for you to go ahead and expand that out. And then when you do get to the lesson on order of operations, which should come up next in our series, then you can, it'll make more sense to you. Okay, so for number 8, we have 2x all cubed, and you'll notice that I put the word all in there. That indicates that there is parentheses. And so this is 2x times 2x times 2x. So now let's go ahead and put in that x is equal to 2. So we have 2 times 2 times 2 times 2 times 2. That's a lot of 2's. 2 times 2 times 2. 1, 2, 3, 4, 5, 6. So 2 to the 6th power is 64. And the last one, number 9. So we have 4x to the 3rd minus y squared. And again, because of where we are, you are probably best off doing it this way. So just like expand that out, and then let's go ahead and put those numbers in. So we have 4 times 2 times 2, and then times 2 and 3 times 3. So 4 times 2 times, that is something or other. That is 32. It's something. 32 and 3 times 3 is 9, and 32 minus 9 is 23. Now, if you did it slightly differently, you structured your work, maybe you did some stuff in a different order. If you landed at the 23, then you're probably fine for how you did it. I'm just trying to avoid assuming knowledge that we haven't covered yet in the video series. And the last one, find the area of a circle with radius 5 centimeters. And I gave you the formula there. That's the formula for the area of a circle. You may or may not be familiar with that. So keeping to good problem solving strategy, we're going to list out our givens. So radius is 5 centimeters. And then we're going to write down the formula that we intend to use. And to avoid any mistakes, I'm going to go ahead and expand that out. So the r squared is r times r. And so we have pi times 5 centimeters times 5 centimeters. Now I want to show you something neat here, okay? If you have trouble with units, okay, so we were given the radius in 5 centimeters. Watch what happens when I go and multiply these, okay? I have 5 times 5, which is 25. I'm going to come over to the right-hand side here just to clear this up. If I have centimeters times centimeters, that's technically centimeters squared. Okay, because centimeters times centimeters is centimeters squared. And so that's where the units come from on our area. You shouldn't need to try to remember out of the blue that length is centimeters and area is square centimeters, because the square centimeters actually comes out of the calculation. And this will happen for all of your area formulas, including, say, area is base times height. If you had 2 centimeters times 6 centimeters, you would have 2 times 6 is 12, and centimeters times centimeters is centimeters squared. So once your math class kind of catches up with your geometry and you learn what exponents are, then that unit on that being a square centimeter actually should make more sense. Now, coming back to the final piece of this, typically what we'll do is we'll take the 25 and we'll move it to the other side of the pi. What's awesome is if you copy it, right? So 25 pi centimeters squared. Now, for some purposes, that would be your final answer. A lot of mathematicians are totally fine with you keeping it in terms of pi, or you may use the decimal approximation for pi and go and do that out. So what do we have here? 2, 6, so 8, 7. So you might get the area is approximately equal to 78.5 square centimeters. And again, which one of those is the answer you want really depends on the context of the problem, what the directions say to do, and what you plan to do with the answer. All right, I hope this helped. As always, if you found this video helpful, please give me a thumbs up and subscribe to the channel so you can get notified when I post some new math videos, or you can send me a message, comment below, and let me know what kind of math videos you would like to see.